Okay, this is the answer key to exercise set 4.1. As you're doing this, or while you are doing this, you should have in front of you your toolkit 4.1, which is product chaining quotient rule, and 4.2, which has the trig derivatives on this. You want to have them out, but as you're doing it, you want to try not to use them. Okay. So again, you need to know those formulas and derivatives for the test. So you want to start building your ability to memorize them. Okay, we're going to get started with A. So we're using the properties you've learned. Differentiate the following functions. Be careful of composite functions that might look like products. First one here, we have a quotient because we have sine x on top, x on the bottom. So that means on my rule sheet, I would be using the quotient rule down here, right? So I know that my f of x is sine x because it's on top, and my derivative of sine x is cosine x, and my g of x will be x, and my derivative of that is just 1. So now I have my values. I can just plug them into the formula, which I'll do over here. So it's going to be g of x, which is x, times derivative of f of x cosine x minus sine x, that's f of x, times 1. That 1 I don't need to put, I'll just put it there so you see where it went, all over x squared. And you're done. That's fine. Okay. Next one we have, this is going to be a product rule because you can see here, right, this is one function f of x, and this is another function here, g of x. So I'm going to write it out to the bottom here. We're going to have f of x equals x squared, derivative of f of x equals 2x, g of x will equal cosine root x, and then the derivative of g of x, this is where it gets a little bit tricky. The derivative of g of x, now this derivative here is going to be a chain rule because we have a function on the outside and a function on the inside. This is not multiplication, it's not division, it's chain rule because it's on the inside of another function. So for that, again, so we toolkit out, that's going to be chain rule. So we take the derivative of the outside, which is cosine. Derivative of cosine is negative sine, keeping that inside the same. And then we're going to take the derivative of the inside, right? So I'm taking the derivative of root x. So let me do this just very briefly cover root x on a separate piece of paper. The derivative of root x, what you do is you change it into an exponent, and then you do power rule on that. So it becomes 1/2 x to the negative 1/2. So I did it here just enlarged for you, but that's what I'm really doing right here. So I took the derivative of the outside. Now I'm going to take that derivative of the inside, which for my other paper was 1/2 x to negative 1/2. So that goes right here, 1/2 x to negative 1/2. Okay. And now I'm going to plug that into product rule. So it's left d right, which is going to be left x squared times all of this. I know it's a lot, but you just put it in one big parentheses, negative sine root x one half x to the negative 1/2, all with one big parentheses around it. Okay, that's going to be plus right, which is cosine root x times 2x. And that is it. Okay. Next up, C, tan x squared. This is going to be a chain rule because, again, it's a function inside another function. So first you take the derivative of the outside function. So again, it's a new function, the derivative of 10. You can always check your paper if you didn't know, but it is secant squared x. So we're going to do secant squared, and then keep the x squared in there, times the derivative of the inside, which is just 2x. That's it. D, we have the square root of a quotient. So for D, we're going to be using chain rule. So let me go ahead and rewrite this with an exponent. So it's going to be x squared plus 1 over x. So I know to use chain rule because I have a function inside another function. And you have to work from the outside in, and the outside function is this 1/2 power. So we're going to take the derivative of that first. So we're going to have just 1/2 and then x squared plus 1 over x all to the negative 1/2. Just like how I did the square root of x. It's the same thing. And then I'm going to take the derivative of the inside. So inside I have, I'll do that over here, x squared plus 1 over x. And you can see this is a quotient rule situation. Okay, so we're going to do f of x equals x squared plus 1. Derivative of f of x equals 2x. G of x equals x. Derivative of x equals 1. Plug it in, you will get x 2x minus x squared plus 1 all over x squared. So this is going to be, I can actually simplify this. That's going to be 2x squared minus an x squared minus a 1. So we're going to get x squared minus 1 over x squared. That's what that simplifies to that. And that's what we're going to put right here. So this is the derivative of the inside. So that's going to go right here. X squared minus 1 over x squared. That is the final answer. So derivative of the outside, keep the inside the same. Derivative times the derivative of the inside. We did the derivative of the inside using quotient rule. Okay, identify f of x derivatives, g of x derivative, plug it into the formula, and that's it. Okay, moving on. We have 1 over 1 plus x. So we have a couple of options for this one. You could do quotient rule, or you could do chain rule. So I think the way I'm going to do it is chain rule. So whenever you have 1 over a value, 1 over anything, you can just rewrite that as that value, 1 plus, I'm going to, on a different sheet of paper, let me show you what I'm doing here. Whenever you have, say, 1 over x, you can write that as x to the power of negative 1. If you have 1 over x plus 1, you can write that as x plus 1 all to the power of negative 1. And when you do that, what you can do is then, instead of doing a quotient rule, you can do a chain rule on it, but only in this kind of situation. So back to this, what I'm doing is I'm rewriting that in form. So that 1 over x is going to be x to the power of negative 1. And all of that is to the power of negative 1. Okay. And then I'm going to do chain rule on this. So the derivative of the outside is going to be negative 1 plus x to the negative 1 all to the negative 2. times the derivative of the inside. Well, that's 0, and that's going to be negative x to the power of negative 2. And that's the final answer there. Okay. Next one, secant x, cosecant x. So for this one, we're going to have a product rule again. You can see multiplication. Secant x times cosecant x. We have an f of x here and a g of x here. So let's do it. F of x equals secant x. The derivative of secant x, again, you should be working on this, is secant x tan x. And then our g of x is cosecant x. And you get the derivative of that again from your sheet. That is negative cosecant x cotangent x. Okay. So left secant x, right cosecant x, and then the derivatives, which you can get from your sheet right now. Okay. And then we plug it in. So left d right plus right d left. It's going to be a little long, but it's going to be secant x times negative cosecant x cotangent x. So this is the f of x right here. This is all the derivative of g of x plus, so this is all like one big multiplication. That is not subtraction. That's just multiplied by a negative. And plus cosecant x secant x tan x. And that's fine. You could simplify this more with the trig identities, but this is fine as it is. So let me circle that so you know this is the final answer. Okay, next one. We have cosine cubed x over x plus 1. So this is a tricky one. This is going to be a separate sheet of paper. So I'm going to rewrite it over here. We're going to have cosine cubed x over x plus 1. So this is a chain rule problem, but it's actually two chain rules. So this cube right here is confusing. This is basically saying the same as cosine x over x plus 1 cubed. These are the same thing. So your outside function is actually this cube right here. So we're going to deal with that first. So we do power rule. So it's going to be 3 cosine squared x over x plus 1. Then, so that was your most outside function. Your next most outside function is that cosine. Then we're going to take the derivative of the cosine. The derivative of cosine is negative sine x over x plus 1. The 2 is gone. The 2 and the 3 we do not care about because we've done that outside of the function. We've broken off that layer. That's gone. So I'm not including that 3 again, right? And then I'm into this. So I've done the outer layer. Then I did the second layer. And now I've got to do the third layer, which is that x over x plus 1. So x over x plus 1. I mean, you can do this in different ways. I'll do a quotient rule. So we're going to have f of x equals x, derivative equals 1, g of x equals x plus 1, derivative equals 1. And then using the rule, we're going to have x plus 1 times 1. I'm not going to write it. Minus x times 1 all over x plus 1 squared. So that just is 1 over, because that x minus that x will go to 0, 1 over x plus 1 squared. And that will go here. So to recap on this one is more challenging because it's sort of three functions inside each other. You have the outside function, which is that cubed. That's his number 1, the outside. Then you have the cosine is number 2. That's the next most inside. And then in here is the number 3. So you start with that outside, start with the 3 on the power rule on the 3, then the derivative of cosine, and then the derivative of the inside. And then this all together is a solution to G. This is G right here. Okay. The last one, H. I think this is going to be another separate page. We have, I'm going to write out here, cotangent parentheses root cosine x plus 1. Okay. So I'm seeing chain rule immediately because, again, I got a function inside another function. So let's do that first. So my outside function is this cotangent. The derivative of cotangent is negative cosecant squared, and then I keep the inside the same. Cosine x plus 1. Then, so again, this is my number 1, my outside function. Then I don't have any multiplication division, but I have more functions inside of each other. Then inside of that cotangent, I have this square root here. This is number 2. It's my next most inside one. So I'll do that just down here below. Remember, I don't care about the cotangent anymore. It's going to be just cosine x plus 1, all to the power of a half. Remember, I'm converting that radical into a half. Then the derivative of that becomes 1/2 cosine x plus 1 to the negative 1/2. So that's going to go here. 1/2 cosine x plus 1 to negative 1/2. And last, I've got this function. This is my inside of the inside. This is number 3. I'm going to multiply by the derivative of that. So derivative of cosine is negative sine x, and the 1 goes away. So all that goes here is a negative sine x. So again, this is like right here. This is like 1. This is 2. This is 3. And that's outside, middle, inside. Very similar to the previous problem. You have the outside, your middle, and then your inside. Okay.